Welcome back, guys. Today I'm going to be talking about how a tick bite could make you allergic to meat. It's pretty scary stuff. Stay tuned for more. Imagine eating a steak for dinner and feeling completely fine, and then waking several hours later with stomach pain, hives, vomiting, or even difficulty breathing. Now, you might not connect the reaction to the meal at all, and you would be even less likely to connect it to a tick bite that happened weeks or months earlier. But that is exactly what can happen with a condition called alpha-gal syndrome, a potentially serious allergy to a sugar found in the tissues of many mammals. Now, unlike most food allergies, it is triggered not by the food itself, but by the bite of a tick. And this one really piqued my interest as I've studied ticks in the past in my scientific research. Now, cases seem to be increasing in several countries, and Australia has some of the highest reported rates in the world. Yet scientists still do not fully understand why only some tick bites cause it, why reactions are so delayed, and why symptoms vary so widely, or how to cure it. So how can a parasite make someone allergic to meat? And why might the condition be becoming more common? Well, alpha-gal is short for galactose alpha-1,3 galactose. Bit of a tongue twister there. Now, it's a carbohydrate, so it's a sugar molecule found on cells and in tissues of most non-primate mammals. So cows, pigs, sheep and deer all produce this sugar. Humans, along with other apes and old world monkeys, do not. Now, normally eating meat containing alpha-gal does not cause a problem, but after certain tick bites, some people begin producing a type of antibody called immunoglobulin E, or IgE, against this sugar. Now, IgE is the antibody involved in allergic reactions. Once the immune system has become sensitized, eating mammalian meat can expose a person to the alpha-gal again. Now, the IgE antibodies recognize it, and immune cells release chemicals such as histamine, and an allergic reaction can follow. Symptoms can include hives, itching, swelling, stomach cramps, diarrhea, vomiting, breathing difficulties, dizziness, and in severe cases, anaphylaxis. And the reaction can be life-threatening. The extraordinary part is how the allergy begins. So when a tick feeds, it does not simply pierce the skin and passively drink blood. Its saliva contains a complex mixture of compounds that manipulate inflammation, blood clotting, and immune responses so that it can remain attached and continue feeding. Now, in tick species associated with alpha-gal syndrome, the saliva can also contain alpha-gal or substances that lead the immune system to react to it. The tick introduces this material directly into the skin. For reasons that are still being investigated, this combination of alpha-gal, tissue injury, and tick saliva immune signals can push the immune system towards an allergic IgE response. Now, the result is a strange biological misunderstanding in the body. So the body begins treating a sugar found in ordinary mammalian food as though it were a dangerous invader. In the United States, the Lone Star tick is the main species associated with the condition, and here in Australia, where I am, many cases are linked to the Australian paralysis tick. Other tick species are involved in Europe, Asia and elsewhere. Now, the condition seems to be particularly relevant in Australia, so some tick-prone regions reported prevalence has exceeded 700 people per 100,000. Suspected Australian cases have reportedly been increasing by around 22% per year since 2020. The United States is another major hotspot, so the US CDC, so the Center for Disease Control and Prevention, has estimated that as many as 450,000 Americans could have the allergy, although many may remain undiagnosed. But those figures require some care, so being sensitized to alpha-gal is not the same as having alpha-gal syndrome. Sensitization means that a blood test detects IgE antibodies against alpha-gal. Some people with these antibodies can still eat meat without symptoms. For example, studies in Japan and parts of Europe have found that a noticeable share of the population is sensitized, but only a smaller proportion has clear clinical allergy. A diagnosis therefore cannot be made from a blood test alone. Doctors need to consider the person's symptoms, their timing, their food exposures, their history of tick bites, and the test results together. And diagnosis can be difficult because alpha-gal syndrome breaks one of the usual rules of food allergy. So most IgE-mediated food reactions begin quickly, often within minutes and usually within a couple of hours. Now, alpha-gal reactions can take 3, 6 or even 8 hours to appear. And remember, that could be weeks and months after the actual tick bite itself. Someone might eat beef at 7 in the evening and become ill after midnight. By then, the meal might not seem like an obvious cause. Some people primarily experience digestive symptoms such as abdominal pain, nausea, diarrhea, without the classic hives or swelling people associate with allergy. That means cases can be mistaken for food poisoning, irritable bowel syndrome, or an unexplained stomach problem. The delay might be related to the way alpha-gal is carried through the body. In meat, alpha-gal can be attached to fats. After a fatty meal is digested, these molecules are packaged into particles called chylomicrons. They travel first through the lymphatic system and then enter the bloodstream. Over the next several hours, the particles are gradually broken down. One leading theory is that alpha-gal becomes accessible to the immune system only after this slow digestion and transport process. That would help explain why the reaction arrives so much later than an allergy to something such as peanuts. But the mechanism is still not completely settled, nor does everyone react in the same way. So a person might eat meat on one occasion without a problem and then react severely another time. The amount and type of food can matter too, so a fatty meal may provoke a stronger reaction because alpha-gal is carried in mammalian fats. Alcohol, exercise, illness and some medications might also act as cofactors, lowering the threshold for a reaction or making it more severe. And the issue is not always limited to obvious red meats. Alpha-gal can occur in beef, pork, lamb, venison, but also other mammalian meats. Some affected people also react to dairy products, gelatin, or ingredients derived from mammals. There was even a case here in Australia where a boy recently died due to alpha-gal syndrome, and reports say that he became ill simply by eating a marshmallow, or simply by inhaling the fumes from cooked meat. So you might not have to consume the meat in the traditional sense to have an allergic reaction. Certain medicines and medical products can also contain mammalian-derived substances as well, but sensitivity varies greatly, so some people need to avoid all mammalian products, others can tolerate dairy, gelatin or small amounts of meat. And that is one reason why medical guidance needs to be individualised rather than based on an enormous kind of universal exclusion list. So why are cases rising? Well, one possibility is that people are simply becoming better at recognising and diagnosing the condition that was previously missed, but ecological changes may also be increasing human contact with ticks. Warmer temperatures can allow some tick populations to remain active for longer periods, survive in new areas, or expand their geographical range. Climate change is therefore a plausible contributor, although tick distributions are also influenced by humidity, vegetation, land use, fire, host animals, and local conditions. Ecosystem degradation, so that's when we damage and destroy and fragment ecosystems, this can also affect tick populations and increase the likelihood of tick bites in humans. Wildlife populations matter too, so ticks depend on animal hosts for blood meals and reproduction. In the United States, Lone Star ticks are strongly associated with white-tailed deer and certain rodents. As deer populations have grown or move into human-dominated landscapes, often because we've fragmented ecosystems, encounters between people and ticks may have increased. Similar relationships exist between deer and tick species in parts of Europe. This makes alpha-gal syndrome more than simply a food allergy story. It sits at the intersection of human health, wildlife ecology, land management and a changing climate. At the moment, there is no established cure. The primary approach is avoiding foods and products that trigger reactions, carrying emergency medication when prescribed, and preventing further tick bites. Some people are also given antihistamines to help manage allergic symptoms, although antihistamines are not a substitute for adrenaline in anaphylaxis. The encouraging part is that the allergy might not always be permanent, but it's still pretty scary. There is evidence that alpha-gal IgE levels can decline when people avoid further tick bites. That might be easier said than done. And after several years, some people may be able to reintroduce certain foods under medical supervision, but another bite can boost the antibody response again. So avoiding ticks is not merely about preventing another uncomfortable bite. It may be central to allowing the immune system to settle. That means using repellents, wearing long clothing in tick habitat, and checking the body after time outdoors, and managing vegetation around homes where appropriate. People also need to be cautious when removing attached ticks, because disturbing a tick can cause it to release more saliva into the body. Current Australian guidance often recommends killing a tick in place using an appropriate freezing product rather than squeezing or pulling at it with bare fingers, although people should follow local medical guidance, especially if they have a known tick allergy. Researchers now want to understand why the condition develops in some people but not others. Does it require repeated bites? Does the tick need to have recently fed on a mammal carrying alpha-gal? Do genetics, skin immunity, and the microbiome or previous allergies affect susceptibility? Are there different subtypes of alpha-gal syndrome? And can biomarkers predict who is at greatest risk of a severe reaction? Scientists are also exploring ways to retrain the immune system, but any treatment will have to be approached carefully because alpha-gal can be encountered through many foods and, as I mentioned earlier, medical products, and reactions can be unpredictable. Patient registries could help by following large numbers of people over time and linking symptoms, tick exposure, and antibody levels. That might also reveal why some people mainly experience gut symptoms while others develop hives or anaphylaxis. Alpha-Gal syndrome challenges some of our basic assumptions about allergy. It is an allergy to a carbohydrate rather than a protein. It can begin through the bite of an animal rather than through eating, although eating obviously plays a role later on. Its symptoms can be delayed for hours, and it links a meal eaten today to an ecological encounter that might have happened months earlier. It also reveals something broader about immunity. Our immune response does not respond to foods in isolation. Its reactions are shaped by the route of exposure, the surrounding biological signals, and the environment in which those encounters occur. A sugar that can be eaten safely for decades may suddenly appear dangerous when a tick delivers it into the skin alongside a powerful mixture of salivary chemicals. So the rise of meat allergy is not simply a story about people becoming sensitive to steak. It is essentially a story about ticks and deer and climate and landscapes and the surprising environmental change that can reprogram the human immune system. And as ticks move into new places and people encounter them more often, alpha-Gal syndrome might become an increasingly important example of how changes in ecosystems can produce changes inside our own bodies. Ecosystem degradation could also be relevant, as I mentioned, by altering the mix of abundance of animals on which ticks feed. In some disease systems, diverse wildlife communities can create what's called a dilution effect, so ticks are spread across many host species, including animals that are poor at maintaining or transmitting pathogens, thereby reducing the proportion of infected ticks. When habitats are fragmented, so when we're destroying habitats and fragmenting them, or when they're simplified, resilient host species that support larger numbers of ticks can become disproportionately common, potentially increasing human exposure. However, alpha-Gal syndrome is not an infection like Lyme disease, for instance, so the same mechanisms can't be assumed. More what we call competent mammalian hosts may support more ticks and potentially more opportunities for ticks to acquire or deliver alpha-Gal, while some biodiversity changes could instead reduce encounters. This ecological connection is very plausible in my mind, but it's not yet been demonstrated as a clear dilution effect for alpha-Gal syndrome. However, as I mentioned in many of my other videos, human health is deeply interconnected with the health of our surrounding ecosystems, so protecting and restoring our ecosystems can only be a good thing for our health and well-being. Thank you so much for watching this video, it really does mean a lot to me, and if you liked it or found it interesting, you can do me a huge favour and click like and subscribe to the channel. It really does help the channel grow and allows me to keep making these educational videos, and remember, stay wild inside and out.